Kia ora koutou. Welcome to this video on gravitational potential energy. Um, we'll get straight into it. Gravitational potential energy is the energy that is held in an object because of the height of the object above the ground. So I've just done a little drawing here. So we've got a box which is sitting on a ledge which is above ground level there. So this box will hold gravitational potential energy because of the height that it is above the ground. There are two factors that will affect how much gravitational potential energy this box has. So the first one will be if this was the mass of the box. So if we think of this box as being maybe 0.1 kilogram, that would have less gravitational potential energy than a box that was 2 kilograms. So the mass of the object affects how much gravitational potential energy it has. Another thing that will affect the energy of the object is the height that it is. So if this was 1 meter above the ground, then that would have a certain energy compared to if this was actually 10 meters above the ground. So if you picture, what would you prefer if there was a box that was going to fall on your foot? If it was 0.1 kilogram box that was 1 meter above the ground, that would be much better than a 2 kilogram box that was 10 meters above the ground, for example. Just to put into context that a heavier box from a higher height will have a far greater gravitational potential energy. It kind of just makes sense, quite intuitive. So what we are going to be looking at is if we have an object that is a known height above the ground and is a known mass, then we can calculate the energy, the gravitational potential energy that that box has. So the formula that we use for that is EP. The E stands for energy and the P stands for potential. So EP, this potential means, gravitational energy effectively. EP equals mass times gravity times the change in height. Energy, gravitational potential energy, all energy is measured in joules. So anytime you see an energy, we're going to come across gravitational energy and kinetic energy, and they're both measured in joules. So EP equals gravitational joules. We've got M equals the mass. We've come across mass before, and remember that is measured in kilograms. Gravity, so G stands for gravity, and that is, you'll be given this in the exam, the value of gravity. It is 10 meters per second per second. So I'll just draw that in here. Gravity is always 10 meters ms minus 2. So we can always just plug that value in. Anytime we see G, we just plug the value 10 into the equation. And then h equals height, which is measured in meters, the same as distance. So h equals height measured in meters. So we'll do an example of this equation. So if this box, we'll just stick with this drawing here. If this box was 2 kilograms, so that had a mass of 2 kilograms, and it was held, let's say, 5 meters above the ground, what would the potential energy of this box be? Well, we just need to plug in the values into this equation. So EP equals the mass, which is 2 kilograms. So we're going to go 2 times gravity, which is 10. So we're just always using 10 anytime you see that G there. And then times the change in height. So remember that triangle means change in. So the change in height, if this was 0 and that was 5 meters, the difference between those two values is 5. So we're going to go times 5. And if we times these values together, we are going to work out what the potential energy of this box is. So 2 times 10 is 20, times 5 is 100. So the potential energy of this box held 5 meters above the ground is 100 joules. we show that with a capital J. So we'll now look at how to rearrange this equation. So the previous equations that we've looked at have all had two variables on the right-hand side of the equation. This one has three, which makes it a little bit trickier to rearrange. We wouldn't be able to put this into a formula triangle like this. So we'll have a look at how we could do it. Just move down a little bit. So we'll write the formula up here. EP equals mass times gravity times change in height. So let's say we had an object that was, say, 4 kilograms. So we've got a box that is 4 kilograms, and we'll say that we know the energy of that box. So we'll say this box has got 50 joules of gravitational potential energy. 50 joules of gravitational potential energy. What is the height of this object that is 4 kilograms and has 50 joules of gravitational potential energy? Well, what we can do is with this mass times gravity, we've seen this before when we worked out the weight of objects. So remember, weight equals mass times gravity. So what we can do actually is, instead of having mass times gravity, is that we can just plug weight into that equation, and then we get energy potential equals weight times the change in height. So EP equals weight times the change in height. So we can actually just put this into a formula triangle now. So anytime you've got something times something else, you put that on the bottom of the triangle. So we've got weight, and then we're going to go times change in height. Oh, that should be a triangle. That's how bad my drawing is. It thinks it's a circle. And energy potential on the top. So we're trying to work out the height of this object here. So to do that, to use the formula triangle to work out the height of it, we need to just put our finger over the height, and then we'll work out that the change in height equals the potential energy divided by weight. So change in height equals EP divided by weight. So we can put that in. So 50 divided by, we need to work out the weight first of all. So weight equals mass times gravity. The mass of it is 4. Gravity, remember, is always 10. So 4 times 10 equals, the weight is 40 newtons. So we're going to put in these values. So 50, the change in height will be 50 divided by the weight, which is 40. So 50 divided by 40, which equals 0.8. Okay, so that's how we use a formula triangle to be able to rearrange this equation. So we can just put weight into the formula instead of that m times g, and then we can rearrange it there, but we still just need to work out what the weight is before we do the formula. So if I was to put 4 into this formula here, that would be wrong, because that would be using mass instead of weight. So we'll leave it there. You'll be able to work out how to rearrange this equation for weight yourselves. Thanks very much for watching. Like and subscribe for more videos.